Exercise 1.2, question 5. Check whether 6 to the power n can end with the digit 0 for any natural number n. So we have to check whether this can ever happen or not. So what are we talking about? We are talking about 6 raised to the power n, where n can be any natural number. Natural numbers are these 1, 2, 3, 4. So we're talking about this. We're saying that if n is any of these, what about the last digit of 6 to the power n? Can it be 0? That is what it means to end with it. Now let me just write down a few possibilities. If n is 1, then this is going to be 6 to the power 1. N is 2, then it will be this, then so on and so forth. This will keep going on forever. Now if you see the exact values of these, you will see 6 to the power 1 is just 6, 6 to the power 2 is 36, 6 to the power 3 is 216, this 6 to the power 4 is 1296, and so on. Now since natural numbers will never end, do I have to write down all of these numbers and then see what the last digit is? The last digit in all four numbers that we have written, the four powers that we took, for them the last digit is 6. So it's not 0. But is it sufficient to just check these four? What about so many others that are left? So this is clearly not the way to do this. We cannot write every power. There is something else we have to think, some other way we have to think that can help us tell whether it ends with the digit 0 or not. Let's see the correct way now. Okay, now if any number in the world ends with a 0, then there could be any number of digits here. The digits could be anything also. The last digit is 0 means I can express it as whatever this rest of the number is multiplied by 10. How did I do this? Just think about it. If I have the number 50, then I can write that as 5 times 10. If I have the number 490, I can just write it as 49 times 10. So whatever is here before the 0, you're really just multiplying that part with 10. So that means if 6 to the power n has to end with a 0, then 6 to the power n will have 10 as a factor. 10 will definitely be a factor of 6 to the power n. Now what is 10 itself made up of? If you see the prime factorization of 10, it is 2 times 5. This means that if 6 to the power n has 10 as a factor, then it also has 2 and 5, because that is what 10 is made up of, right? So this will mean 6 to the power n has 2 and 5 as prime factors. I don't know about the other factors that this might have, because I have no idea about what this number is, but this is the guaranteed part that I can say. If it has 0 in the end, then it has 10 as a factor, and then it has 2 and 5 as prime factors. And this is what we learn from a page from your NCERT book also. And this is what we understood here, how ending with a 0 means the connection with 10 and therefore with 5. Now this is a very important part that we have gotten here. We want to now focus all our energy on this. Let me just clear up some space and we'll see how this takes us to the final answer. Alright, so 6 to the power n has 2 and 5 as prime factors. Now 6 is what? Think very carefully here. 6 as a prime in its prime factored form is 2 times 3. So 6 to the power n really means 2 to the power n times 3 to the power n. Why? Because 2 times 3 to the power n, you can just put the powers separately on each of these numbers. So this tells you that the prime factors that 6 has are 2 and 3. So 2 and 3 are, let's just call it PF, are prime factors of 6 to the power n. Now, according to the fundamental theorem of arithmetic, the prime factorization of a number is unique except for the order in which these prime factors occur. That means it's only about what is written first and what is written later. So it means I can only write this as 3 to the power n times 2 to the power n, and that would still mean the same thing. It's not as if I can start having some other prime factors altogether. So it is not possible that 6 to the power n has any other prime factors except 3 and 2. That means it is impossible that 6 to the power n has 5. This 2 is okay because I see the 2 here as well. But the other prime factor that it has to have is 3. It cannot have 5. That means this statement, this result that we had reached from all our discussion is actually impossible. Now think about it. How did we reach this? We saw that if a number ends with 0, then it has to be divisible by 5. Now you know it is not divisible by 5, so it cannot even end with 0. So that was the thing we had to check. Check whether this ends with 0 or not. So you will say no, this can never end with the digit 0.